Welcome. In the previous video, we added predicates to our string view library, and in this one, we are going to start implementing a tokenizer. We can start by creating a tokenizer.h file. Then, as usual, we can add all of the boilerplate code. We can include stdio, stdleave, and stringview.h. And now we can define our tokenizer. It is going to contain the string view that we want to tokenize, and the current location of that string view. We obviously need to define location, and the location is going to contain a path of the file that the string view was extracted from. It is also going to contain the current row, and finally, the current column. We can now define a constructor for our location that is going to have the following implementation. We can also add a constructor for our tokenizer, and is going to have a similar implementation. Note that the location is going to begin at row 1 and column 1. We can also define a token that is going to contain a token kind. The token kind will be defined as an enum that is going to contain the left parenthesis, the right parenthesis, and end of file for now. Each token is also going to contain a value, and each token value is going to be defined as a union, in this case containing just a symbol that is a string view. Finally, each token is going to have a location associated to it. We can now add a token constructor that once again is going to have a similar implementation to the other ones. Now we can start building a more interesting function called tokenizer shop, which is going to shop a single token from the tokenizer. To define tokenizer shop, we are going to need some helper functions. In this case, tokenizer advanced location, that is going to advance the current location of the tokenizer given a string view. We are also going to need tokenizer shop sv prefix, that is going to shop an sv prefix from the tokenizer and advance the location. And finally, we are going to need tokenizer shop sv while, which is basically a tokenizer shop sv prefix but with a predicate. So we can start defining our tokenizer shop function. We can start by defining the result, which is basically a token of end of file with no value and the current tokenizer location. Then we can ignore all of the white spaces that prefix the tokenizer string view. For that, we can use the tokenizer shop sv while with sv space predicate. In the case of reaching end of file, we can return the current result. We can also set the location of the result, and after that we can start checking for symbols. In this case, we can use sv as prefix given the tokenizer sv and the sv of left parenthesis. If the tokenizer string view is prefixed by a left parenthesis, we can shop it. We can give its kind to the current result, and finally we can return the result. We can do a similar thing for the right parenthesis. Finally, if we reach the end of tokenizer shop function, we need to report an error because we were not able to create a token with the provided string view. We can now include our tokenizer in our main file. To do that, we can define tokenizer implementation and then include tokenizer.h file. Also, do not forget to create the sv macro in our string view library, which is just going to replace it via the sv make function. In this same string view header file, we are going to need to define sv ispace, which is once again just going to be a simple wrapper of the ispace function from C type. Now in the main file, we can delete the previous video code. We can extract the source file path into a variable. Don't forget to replace the parameter by the variable. And to test things, we can first shop a token and then shop another one. In our demo file, we can replace the current content by a left parenthesis followed by a right parenthesis. As you can imagine, we can add as many white spaces in between as we want. Executing the run script will result in two tokens as we expect, one in this location and another one in this location. These locations are quite interesting because they allow us to report very good errors. And this is how you create a tokenizer able of parsing left parenthesis and right parenthesis. In the next episode, we are going to parse IDs.